This is Physics 2211 Lab 2 Projectile Motion by William Barron. Now, the purpose of this lab is to observe the projectile motion of a thrown object, analyze its trajectory using tracker, and then develop two computational models in GlowScript, one including only gravity and the other including both gravity and drag. Lastly, we will then compare the different models. Now, this should show that the model with both gravity and drag is the most accurate to the experiment. The fundamental physics principles used are the velocity update formula, which says that V final equals V initial plus F net over m times delta t, and it allows us to predict an object's velocity as it moves. The position update formula, which says that the final position equals the initial position plus the average velocity times delta t, and it allows us to predict an object's position as it moves. And the drag force, which is equal to negative b times v squared times v hat, which is used to calculate the effect air resistance has on the object as it moves. Systems and surroundings. In this lab, the system is the paper ball and the surroundings are everything else. And the forces acting on the paper ball are gravity and drag. Observations from the experiment. The mass was 1.5 grams. The starting time was 0 seconds and the end time was 0.533 seconds. The initial position was 2.036 e to the negative 22, comma, 1.664 meters, and the initial velocity was 2.67, comma, 1.24 meters per second. And this was calculated using um, V equals delta R over delta T. The tracker data. This is the graph of the paper ball as it was thrown, showing that in the y direction, a parabolic motion. Observations from the model. Using this code, we will get a model that will show the ideal version of the paper ball as it was thrown, which is the model using gravity and drag. Now, to get the model with gravity only, we just change the b equal to 0 so that there is no drag accounted for. And plugging in the formulas previously stated, we will get the information in this code. Now, as you can see, the gravity only model shows two vectors, a gravity vector in light blue and a velocity vector in purple. Now, with gravity plus drag, there is an additional orange vector in the opposite direction of the velocity, which is the drag. Comparison. This is the graph comparing the experiment to the model of gravity and the model of gravity plus drag. Now it shows that the gravity plus drag data and the gravity only data somewhat match the tracker data, and this is due to possible sources of error that will be discussed later. What does this mean? Do any of your models predict a terminal velocity? The models do not predict a terminal velocity since the net force is not zero. An experiment to show terminal velocity would be an object falling straight down. What if it was initially thrown straight up? If the ball was initially thrown straight up, it would hit the ground faster because the object would only be moving in the y direction, while the projectile motion moves in both the x and y directions. So moving a further distance equals more time, and that's why it would hit the ground faster if it was thrown straight up initially. Possible sources of error. Throughout this experiment, there might be some errors. Now, this could be due to a number of things, such as human error or mistakes in calculations. Now, this is not to say that all of the experiment is wrong, but that some minor errors have changed the overall outcome. So, in this lab, the motion of the paper ball was analyzed experimentally and then compared with two computational models, one with only gravity and then one with both gravity and drag. Now, due to possible errors, the data did not perfectly match either model. However, the overall trend showed that the gravity plus drag model provided a closer approximation to the experimental motion than the gravity only model.